Welcome to the fourth lesson in session 2 of problem solving. In our first example, if $2,000 is invested at 6.5% interest, compounded monthly, how many years will it take for the money to double? For this problem, we're going to revisit the compound interest formula. If you remember from the previous session, the compound interest formula reads A is equal to P times the quantity of 1 plus R over N to the NT power, where A represents the amount of money we have at the end of the investment, P represents how much money we initially invest, R represents our rate, our interest rate, N represents how many times per year our interest is compounded, and T represents how much time it's going to take in years. So for this problem, we have the following values. The value of P is 2,000. That's what we're initially investing. And we want to see how many years it's going to take for our investment to double. So for that reason, the value of A, the money we have left at the end of our investment, is going to be equal to 4,000. The rate at 6.5% gets expressed as 0.065. T is our unknown. We don't know how many years it's going to take, so that's the value that we're solving for. And N represents 12, because our interest is going to be compounded monthly, 12 times per year. So we set A is equal to 4,000 because we want to double our investment. So it reads 2,000 is equal to 1 plus 0.065 over 12 to the 12t power is equal to 4,000. Now simplifying all that on the left, first we have to divide both sides by $2,000, which gives us 1 plus 0.065 over 12 to the 12t power is equal to 2. Now we have to evaluate the base, so putting that into a calculator, 1 plus 0.065 over 12 is equal to approximately 1.005416, repeating. Now we're going to take the log of both sides, since we have an exponential equation that we need to solve. We take the log of both sides, which gives us the log of the base to the 12t power, and on the right side we get the log of 2. Using the power property of logarithms, we're going to pull 12t out in front, giving us 12t times the log of 1.005416 repeating is equal to the log of 2. And now we're going to isolate our variable. So we divide both sides by 12 and the log of 1.005416 repeating, and that gives us a value of t is about 10.69. So it will take 11 years for this money to double. In the next example, we're going to calculate continuously compounded interest using the PERT formula. A is equal to P times e to the RT power. The variables are still the same. A represents the amount of money we have left at the end of our investment. P represents our principal, which is the amount of money that we start with. R is our rate, and T is our time. Continuously compound interest means that your principal is constantly earning interest, and the interest keeps earning interest on the interest earned. So if we invest $1,000 at an annual interest rate of 5% compounded continuously, calculate the final amount you will have in the account after 5 years. So we're trying to find out what the amount is. So we initially start off with $1,000 at 5% compounded continuously for 5 years. So that looks like 1,000 times e to the 0.05 times 5 power. So we can plug this directly into our calculator, and we get $1,284.02. In our last two examples here, the first one reads, an amount of $3,000 is deposited into a bank paying an annual interest rate of 6% compounded continuously. How long would it take for the money to double? So in this case, we want to end up with $6,000. We're going to start with $3,000 times e to the 0.06t power, because we want to figure out how long it's going to take for our money to double. So the first thing we have to do is isolate the exponent part. So we divide both sides by 3,000, giving me 2 equals e to the 0.06t power. Next, we're going to take the natural log of both sides. So the natural log of 2 is equal to the natural log of e to the 0.06t power. Now again, on the right side, we know the natural log of e is equal to 1. So that gives us the natural log of 2 is equal to 0.06t. Now if we divide both sides by 0.06, we can isolate t and get 11.55. So it would take 12 years for the money to double. Finally, how much money would you have to invest in an account earning 8% interest compounded continuously for it to be worth $1 million in 30 years? So here we know we want to end up with $1 million. We're trying to figure out how much money we want to start with. So 1 million is equal to P times e to the 0.08 times 30. All we have to do is isolate P and evaluate. So we can divide both sides by e to the 0.08 times 30 power, plug that into our calculator, and we would get $90,715 or $717.95. So if we invest that much money, $90,717.95 into an account that's compounded continuously, earning 8% for 30 years, we will be millionaires. That wraps up this lesson. Good luck on the test and the quiz, and please email us if you have any questions.